So let us discuss this snippet of the sample project. Let's see the directory structure and then what is there. Before that, let's talk of what requirements this system is solving. So it is about a ticket management system. There are customers and they sometimes become unhappy. They raise complaints, which we call tickets, and then people are managing those tickets. Essentially, we are doing a create, read, update, delete on customer entity and the same on the ticket entity. So that's what this project is. And these are the directories. Bin has the final executable. Obj has the .o files. So in this project, we have three .c files: customer.c, ticket.c, and main.c. So customer.c handles all the CRUD operations of customer. So create customer, update customer, delete customer, find customer, print all the customer list. And most importantly, two more things: loading from the data file and saving to the data file. The way the data structure are designed is things are loaded from the database, you can call it. Actually, it's CSV file. Things are loaded from the CSV file and then they are kept in memory. And then operations are done on the memory, and then later the list can be committed back to file. SRC has the source files, include has the. So SRC, I have added one more source file, config.c, which is to do with any configuration parameters. Till now, it doesn't have the code added, but include files are there. In addition to customer.h and ticket.h corresponding to customer.c and ticket.c, we have a common .h. There are certain things which are very common. For example, let me show. Like success and failure. Customer operations also encounter and task operations also encounter success and failure. So where do I put it? Can I put in customer.h, task.h? No. I need to have a common .h. And similarly, some other very common things. Make has the make file. Now let's see it running first and then I will get to the code. So the way to run is first you make it. I will do make clean first and then you make it. So it makes the project, compiles the three .c files and links the three .c files together. Now we go to bin. So I will say .output and I just run it and it gives me a menu. It's a menu driven application. I can keep doing operations. So the way it works is initially we load the data from file. Then we do lot of add, search, update, delete, and we keep printing it to verify that things are working fine. So we do lot of CRUD operations and finally we save it. We save it back to the file. So that is the sequence it works. So currently I can demonstrate, you can load it. So I can say 1, it asks me which file name. So I can maybe following the directory structure, I should say something like that. So and it reads. Currently the customer has 4 fields: ID, name, age, and address. Now let me just print the customer list 7 and it prints it. Some more functions are yet to be written. So that's the running demo. I have written something for the customer, nothing for the ticket yet. And let's now understand the code. So maybe we can start from the include files. That gives us a very clear picture. Customer.h, it defines this structure where we store information of the customer data. It has ID, name, age, and address. I need not write customer ID or customer name here because I am in the context of the struct customer. So I will only write ID. And in the struct ticket also I will write only ID because by my container entity, I know that this ID is of customer and this ID is of ticket. So I need not have a long name like customer name here. Let's look at customer.c. So this is the global data structure. It is simply an array of structures. It's one variable tracks to what extent this array is filled. That means how many customers are currently present. So this is what this sample thing demonstrates. You can feel free to choose other alternatives. Maybe you can have a array of struct pointers because maybe you say that one struct is big size and wastage of memory. So I will do malloc only for those structures who are actually filled. You can do that. Or maybe you want a dynamically allocated array and you are willing to take the complexity of expanding the array as new customers get added, just like a C++ vector expands. Or maybe you wanted to make it a linked list of customer. You can add a next field in the customer T and you can make it a linked list. Or maybe you are unhappy with order and complexity of linked list. You want a tree. You want customer T star left, customer T star right, and you want to enjoy the order log n complexity of tree. Or maybe you don't want order log n, you want order 1 complexity. So you can make a hash table. But anyway, this simple code takes the most simple approach, array of structures. So how does it work? Let's understand. So this is load customer data. So it takes the file name and it simply opens the file and it keeps reading one line at a time, and it tries to parse that line into 4 fields: ID, name, age, address. If that parsing goes successful, then whatever was read is added to that array of structures. Okay, this highlighted code is adding things into the array of structures. 2 integers are assigned just like that. 2 strings are copied. Notice I kept name and address as statically allocated array, so I didn't have to do malloc. Had you kept them as char star name or char star address, you would have needed to do malloc. So it's up to you. It is your choice which one you want to use. So that's simply the reading logic. So that's loading from file, and display of course is simple. You can have a for loop going through each structure and you print each structure attributes. So this is just doing this much, loading and printing. Saving and the CRUD is yet to be written. One more thing, we should see the main. So that was the core code, but main is the driver code. Customer.c provides the utilities CRUD operations, but main is what ties it together. So this is main. It is basically a menu. So we can simply have a kind of combined menu. The customer operations and ticket operations which we can add can be given in a big menu, and then based on the choice you call the appropriate function. That's it. Main has nothing more than just a loop giving a menu, asking the user what to do, and invoking the function. Sometimes asking the user more information also, that okay, you want to load customer data file, so asking the user, okay, give me the file name, then calling the function with that data. So basically it's kind of taking care of the input output with the user. Normally the add customer, delete customer, update customer, modify customer, they will not do printf scanf. They should only operate based on the arguments given to them. Who does the printf scanf? This driver loop. It gets all the data from the user, and the functions, normally any utility, any data structure functions are designed such way that they work only on argument, not on printf scanf. Of course they can do scanf at times, but not much. This is the broad skeleton of the project.